Good afternoon. 2022 is the 20th anniversary of OGS-led 3D sediment mapping. Many of you have been with us since the beginning, but just as many will have joined us along the way. This milestone is a great time to look back at our mapping program, some of the key drivers, where we started and how we have grown, where we are now and where we are heading. This map of Southern Ontario shows the location and project lead for the 5 completed mapping projects, as well as the projects Riley and I are working hard to complete. The areas marked with the white stars are where it all began: Waterloo region west of the escarpment in 2002 and the Barrie-Oro-Moraine area to the east of the escarpment in 2003. There are many reasons or drivers for working in these areas. There are generally areas characterized by thick and complex sediment packages which bury deep bedrock valleys and hide escarpments. Niagara isn't the only one. People rely on groundwater for drinking, industry, and agriculture, and because these areas are populous, there are many threats to water safety. Population growth is leapfrogging beyond the greenbelt, often to communities targeted by places to grow. And finally, we have emerging drivers such as old oil and gas wells. Within each area, we have the flexibility to address local needs. In the early years, Andy and I, along with the rest of the international 3D modeling community, wrestled with some pretty fundamental problems. In 2001, at the inaugural 3D mapping workshop, we focused on the data needed to make a model and the best way to integrate data that ranges from plentiful but really bad to much more sporadic but really good. Data quality and resolution dictates modeling approach. The image on the left is a voxel model I pinched from TNO. In a voxel model, each cell is assigned a series of parameters like grain size or hydraulic conductivity. You can do this if you have lots of really good data. But in Ontario, most of our data comes from water well records. And don't get me wrong, I'm darn glad to have them. But it does mean that constructing a regional scale framework of layers where each cell in the layer gets assigned the same value is about all we can do. It is also necessary to lump geologic units together and model what we commonly refer to as hydrostratigraphy. The early years also saw a progression from using ViewLog to data mine and the creation of scripted routines to streamline picking unit tops, creating wireframes, and finally generating the block models and final outputs. We also developed many of our core products released in groundwater resources studies, such as our reports, GIS grids, databases, as well as Google Earth functionality. Since then, we have expanded our geophysical toolkit. Gravity surveys are a key first step in areas with buried bedrock valleys. An electromagnetic survey helped constrain the valley fill in South Simcoe. More recently, for many years, a successful collaboration with the GSC provided downhole geophysics and shallow seismic surveys. On the modeling front, we were able to start weighting our data so that the model surfaces better reflected high-quality data. We also experimented with merging models. Weighting stuck, but merging didn't. Uncertainty and how to address it is a big deal at many surveys. But as Andy and I both came from superficial mapping backgrounds, our way of dealing with the problem is simply to show the distribution and quality of the data used to build each surface. Lots of good data, probably a reasonable surface. Control points and not much else? Well, it's probably down there somewhere. We have also added to our products over the years. Borehole releases with photos, graphic logs, and analytical data are now the norm. But my hands-down favorite thing I've ever worked on is the magical map Julie and I created for Orangeville. So where does that leave us? Well, Andy has retired, leaving Riley and I to carve up the province. When I'm not skiing, I'm your go-to person west of the escarpment. And as soon as Riley is back from parental leave, he'll be ready to answer all of your questions to the east. In the remainder of this talk, we will explore some of the key findings from each of these groups of projects. Starting in the west, let's take a moment to look at the composite section which extends from Waterloo to Niagara. We can see the Onondaga and Niagara escarpments as well as a buried bedrock valley. The sediment record begins with a package of older deposits capped with Catfish Creek till, which was deposited during the late glacial maximum. With the breakup of the regional ice sheet and shift back to distinct lobes advancing out of the Great Lakes basins, interlobate sediments, including the well-known Waterloo and Orangeville moraines, were deposited high on the landscape in a series of ice-walled lakes. As overall retreat continued, deposition shifted to a series of end moraines, including the Paris and Galt moraines. And finally, deposition shifted even further to the Niagara Peninsula, where glacial lacustrine clays, separated by a wedge of halton deposits, dominate. Considering the entire sediment package, we can see that there are aquifers in several settings. Recharge of bedrock aquifers will be enhanced in areas with little or no sediment cover, or where rock is covered with just sand or gravel, or where the ground surface is hummocky, as is found in some moraines. Bedrock valleys often host one or more distinct aquifers, while both regional and local aquifers are found in glacial and non-glacial deposits below Catfish Creek till. Interlobate moraines and ice marginal fans and deltas form large and partially confined aquifers. And finally, coarse gravel outwash aquifers are important for both base flow and cold water streams. I'm going to pass rapidly through a series of slides that list many of the publications for each project area. So grab those cell phones or just wait for this presentation to be posted on the YouTube channel of the GSC. A great demo at the end of the day will show you how to find all of these great publications. Now for the Waterloo area, I'd like to draw your attention to the final GRS, that's number 3, as well as the special volume published by the Canadian Water Resources Journal in 2014. The Orangeville-Fergus area features GRS 15, the magical map, and a paper in the Canadian Journal of Earth Sciences special volume, which was published in 2018. Work in the Brantford-Woodstock area resulted in GRS 10, and of course there were many summary of fieldwork reports. Work is still progressing on the Niagara Peninsula. However, there are still many great publications to get you going, field summaries, borehole data, as well as geophysical data. We could take a similar approach east of the escarpment. Here I've used a conceptual section from South Simcoe to represent the 3 project areas. The Niagara Escarpment and Laurentian Trough area with multiple inset valleys are clearly visible. An older drift sequence consisting primarily of consolidated diamicton is overlain by non-glacial sediments spanning the Sangamon interglacial and earliest part of the Wisconsin episode. Next, thick glacial lacustrine sediments were deposited in an ice dam lake fronting the advancing Laurentide ice sheet. Subsequent overriding initiated deposition of Newmarket till, which continued during and after multiple phases of tunnel valley erosion. The final group of sediments includes late glacial and post-glacial gravel, sand, silt, and clay associated with the interlobate Oak Ridges moraine complex in the south, ice marginal Kame Terrace deposits along the Niagara Escarpment in the west, and ice contact and glacial lacustrine sediments infilling low-lying areas. Once again, this complex sediment package hosts multiple aquifers. Deeply buried aquifers overlie bedrock in Laurentian Trough, and there are also aquifers with more limited spatial extent and recharge potential within the older deposits. Organic material within non-glacial deposits contributes to poor water quality, but more promising are the multiple discrete aquifers of the Thorncliffe Formation. This includes productive aquifers near Georgian Bay in the north, as well as south in the Oak Ridges moraine area. Perhaps more infamous are the pressurized aquifers within the Tunnel Valley Fill. And unconfined aquifers are found along the Niagara Escarpment and overlying Newmarket till. And finally, there are also widespread unconfined aquifers in the lowlands. The Barrie Ore Moraine project was the first completed for this area, and the final results are published in GRS 11. The South Simcoe project was a great collaborative effort. Note the multiple geophysical and geochemistry releases, in addition to a new superficial map and GRS 18. And finally, as with the Niagara Peninsula project, there are many interim products for the ongoing Central Simcoe project. So what's next? Well, I have a project in the Guelph area that is in the planning stages. We are hoping to get a ground gravity survey rolling before too long, and Riley will be heading east and focusing his attentions in the Ottawa area. I'm very excited to be able to give all of you a sneaky preview of the brand new cross-section viewer tool that Galen and Patty from Aqua Insight are working on. The tool is based on the published model grids and allows you to show either the top elevation or isopac map of your chosen unit in the top window. The pick data points can be filtered to show everything or just high quality picks, while the bottom window shows the resulting cross-section. Note the cord boreholes and pick data overlying the section. There is a small pop-up which shows unit thickness, and you can zoom in or out to adjust the vertical exaggeration. Riley and I are experimenting with different derivative maps. The image on the left shows how much of the total sediment package is potential aquifer material, regardless of its stratigraphic position. Keep in mind this is calculated based on units from our framework model and not voxels. The image on the right provides a plan view of the stacked units. For example, orange shows where there are potential aquifers at surface as well as buried by a confining layer. Please let us know if there is something else that you'd like to see. An ongoing collaborative project led by Liz Priebe aims to characterize the hydrogeology and hydrochemistry of the main units in Simcoe County. Part 2 of the project is to map regional groundwater flow systems within these units, including the identification of recharge areas and an assessment of hydrochemical evolution. And finally, with Julie's help, we are turning our attention to cleaning up the legacy geotechnical borehole database. New features include location mapping, filters, and the ability to view and export information from selected boreholes. Before handing you over to our next speaker, I'd like to introduce you to the rest of our great quaternary mapping team. First up is Robert, our section manager. For those of you who aren't familiar with our org chart, Robert has taken over from Richard, and before that, Ross. George, who led the seamless drift thickness mapping team, has been working with Key Young on 1 to 100,000 scale remote predictive mapping in the far north. While closer to home, Andrea mapped her way across the clay belt in the vicinity of Hearst and has now started a multi-year superficial mapping project along the Highway 17 corridor. Grant, the newest member of our team, joined us in January. He's already hard at work on till geochemistry and indicator minerals. And with that, thank you very much for listening.